Hello everyone, I am Suryakant. So this is my third demo. Let's get started. So in the previous demos, we have discussed about our project payment integration system with Stripe and our e-commerce client. Okay, so let me give you a brief summary about our project. So our project aim is to integrate with Stripe service provider, payment service provider, and here is our e-commerce client. Let's see, e-com client, and here is our payment system, payment integration system, and here is our let's Stripe. Okay, in this project we have followed, we have adopted microservice architecture. So for this project we have developed three microservices, and the first one is validation services, and this is our core payment integration services, and this is our Stripe provider. Okay, validation, this is our core payment, this is our Stripe provider. Okay, so first of all, our e-commerce clients send all the requests for the validation purposes. Okay, then after the validation, this validation microservice or services will send a request to our core payment client. Then our core payment client will send a request to the Stripe provider services. Okay, okay, sorry. Let's see. Our validation services sends request to the core payments after the validation, and our core payment systems store it into the database. Let's see, this is the database. Okay. After that, then our core payment services sends a request to the validation services. Then the validation services another again sends a request to our core payment services for to request to the Stripe. Okay, with all the details of the end user or end customer, with product details also, and then our Stripe sends a request to the our Stripe provider services sends a request to the Stripe PSP, Stripe third party Stripe payment service provider. Okay, then Stripe PSP responds back with an URL. What URL? URL to redirect our end customer to a Stripe hosted payment page where our end customer will complete the transactions for the product he wants. Okay, our Stripe provider sends a response with a URL, and this URL sent to the core payment, and again our core payment talks to the validation services. With that, validation services talk to our e-commerce client. With that, our end user is redirected. Let's say end user, it's the Stripe posted payment page, posted page. Our end user is redirected with the URL, the validation service or Stripe provided. After that, it completes the transaction and gets the product. So it's the core gist of our project payment integration system. But our responsibility, or it's my responsibility, is to build the payment status functionalities. What is status? There are many status. First, let's say one status created, that the payment is or created. It is created when the e-commerce client is ready to check out. Then the validation services validates its request and sends a request to the core payment system. Here we set the status as created, and there are many status like initiated and pending and success and let's say failed at last. Okay, so we have to develop these functionalities so that in the database we store all the status for a end user. If he is initiated the payment, is created the payment, pending, success or failed. Okay, for these statuses in the entire system, there are multiple hook points are there, right? There are multiple hook points are there. Let's say this is our core payment integration. We'll work on this core payment integration. In this, we will develop the payment status functionalities. Okay, so this is our core payment system. So, okay. For the building the status functionalities in the entire system, there are multiple hook points. What are hook points? Let's let's say we got a request from the validation services. Okay, that to set the status as validated, or after the validation we will set the status as created, right? Here is the validation. There is another hook point. What is that? We have made a call to the Stripe payment service provider, Stripe PSP. Then we will set the status as what? Initiated. We are called the Stripe PSP, then we are setting the status as initiated. Okay, here is our Stripe PSP. Then our Stripe PSP request back, sends response back to our core payment systems. Then we're gonna set the status as what? Pending. Okay. Then this is the pending request. After that, the end user or end customer is directed to the Stripe hosted payment page, as you have already seen here. Redirect to the payment hosted page. Then, after completion of the payment, Stripe PSP sends a webhook or notifications. Let's say webhooks or notifications. Here, we then update the status as success or fail. So our responsibility is build these statuses. So what will be our approach? Let's say a normal approach, first approach, that we can write like this, that the payments service, the payment service class, in that we can write a method process status. It accepts string status. Okay, then let's say if the status is equals to created, we will perform this. Let's say we have to store in DB. Store in DB. Yes, so we have to send an email. You can write all the logic here. As like this, you can like rewrite all the statuses. That if status is not created and initiated, let's say initiate, we can write like this in the one payment service class, our payment service class, right? You can write like that. We can write all the logics here. No, but it's not as that simple, right? It's we are built as a, it is a single responsibility, but the creation status creation is a itself is a mm, bulk process, and status initiated class itself is a bulk process. And if we write all the logics here in one class, it's many problems will be faced for debugging, for error handling, and it's not at all recommended. So what we'll do for that, we'll do approach. Our second approach will be write using our second approach. We can write group related logics. You can groups all the related logics and extract them to separate methods. Okay, then we will invoke these methods to this individual methods wherever required. How will do that? Let's say the status creation is a method. For that, we'll create a separate method, that is process created. Okay, status. This will be a method in that we can write our logic. Let's say storing DB, all the logics here. Like that, we will also we can create process initiated status. Okay, that also we can write here all the logics which we require. Like that also it can be we can create for the failed status or initiated pending status, all that. And for that, we copy this another and can okay. For that, we have to just invoke this method wherever required. That means we if the status is created, then we will invoke this we'll invoke this method to this field. So for that pursuit, for that we have to just call process created status method. Okay. Let's say for the reset status, we'll call process initiated status like that. Okay. But what if we now wanted to set a or store a new status? Let's say new status called processing. We now want to build a new status called processing. For that, we have to go through all the methods and a new developer comes and a new status you have to uh, build in that system. For that, he have to goes all these methods and studies all the what method are working in which field, right? So that it is not recommended to build the logic in all the methods in the one class. Okay. So our industry coding standard says or microservice standard says also open for extension, closed for modifications. We do not want to touch. these classes or methods rather than we add all the status but don't modify this class. For that, we have to build the classes. For that, our approach will be to move all the methods into separate classes, Java classes, and create objects of those classes and invoke the methods. Like that, let's see what will be the our approach. Here we have to separate all the methods to different classes. So let's say is a class for created status handler, right? Here it's a class called initiated status handler. Okay. So here is a class called pending status handler, like that. Okay. Then for the invoke of these methods, we now need to write that. Let's see it. For that, we have to create first the object of these classes, created status handler obj equals to new created status handler, right? And then we have called the object also obj dot process created status. Okay. With the same thing we have to for the initiated status handler. Initiated status handler. Okay. And here also we have to process created status handler. Any status handler. But see here, here all the we have separated all the methods into separate classes, and in these methods we are invoking here as required. But in all the classes, we got to see if something unique patterns are there. The same patterns are there in all the classes. So it's better to use all of these in a separate. You have to
It's better to inherit, or let's say we have to inherit from a child, right? Here, all the 100 classes have common patterns, have processing some status, and they are processing some status and have common pattern for them, right? So, this is what is the both approach. Let me copy like that. Let me clear. Okay. So now let's inherit from a class, or for that creation of the parent and inherit these classes to a child, we have two options. First one is interfaces and the second one is abstract classes. But in this project here we will go through the abstract classes. Why abstract classes? Let's say in the create status handler, here is the process created status, right? Okay. But we need a common method which is required here also, which is required here also, which is required here also. For that, if you are using interfaces, we have to implement all this method in the separate classes also. We don't want that. For that, we'll use here abstract classes, right? So let's say for the our non abstract classes, but payment status handler. So, visible. Yeah. So, let's say our parent or abstract class is payment status handler, right? In that abstract class, we'll inherit all the classes from that abstract class, right? Yeah. For that, we have to a method here which we'll implement here also. Let's say what is the method? Uh, then we'll write the method here. Let's say process payment, a process status, right? For that, we have to inherit or implement these methods here. So process status like that. Here also we need the same name, process status. Right. Okay. Okay. For invoking these methods, we need to now create the parent auto object. Let's delete it. And here what we'll do for invoking this method, we invoke this from parent and let's say created status, right? And then with that handler, we will call the method handler dot process payment. Okay. Here also we'll do the same that, but without created instance, we are here initiated status handler, right? Like that. That is okay. But see here, what is the problem? You it is just check the status and calling the require handler, right? Here also it is just checking the status and calling the required handler. It is the pattern is same, the logic is same here. Just it is process the status. Why not let create, okay? For dealing this issue, we have come upon the factory design pattern. So what is that? It is that the writing method. Okay, let me do the what is factory design pattern. Factory. What is that? Is the writing method which takes some parameter as input and based on that parameters decides which object is to return or which object is to create, and the return type is parent type or parent class type. Okay, so let's say we will write a method like payment status factory is the class, and inside that we will write our method public. Let's say return type is also payment status handler, so payment status handler. With that, well, the method name is get status handler, right? And it is take the parameter string status and we'll write here If this status is equals to created, we will return created status handler, right? New created status handler of this object. For the status initiated also will be the same logic. Let's say here also we write, yeah, if the status is created initiated, then also we will return here or initiated status handler. Status handler, right? So for that, let's take it to the, here. We will write here our factory design pattern. Factory design. Okay. So there we write our factory design pattern. So, right. Now we don't need this. Okay. Just give it down using just three line. What three line? Yes, it also. Let's say payment status factory factory equals to new factory. Okay. Then factory dot, yeah, this here. Factory dot payment status handler. Or get status handler. Their method name. So right here also factory dot get status handler with string with status. Okay. Then here's the factory will return a payment status handler. So payment status handler handler, right? Okay. Then this handler, using this handler, we will call that process status. Okay. So now this 10 lines is now converted to these 3 lines only. So take it also and delete like that. Our payment status system, its payment status function system is built. Thank you so much.